Hey, today we're doing a Codeforces Div 4 round, but before we get started, I wanted to give a quick shout out. Congrats to Gennady, also known as Tourist, for hitting the 4,000 rating on Codeforces. This is the first time anyone has ever reached a rating this high, so it's a big deal, big congrats, and alright, let's get started with the round. Okay, we're just printing A minus B. B minus A, I guess. I'm not even going to. That's not how you spell submit. I can't submit. I'm not going to. Okay. Oh, here we are. I'm too late, but okay. I'll use this for B. Oh, what? Oh, so we're just doing, okay. Hard problem to understand. Vector answers. Did I have to do this to submit? It didn't submit? I got Cloudflare blocked from submitting. Oh, Codeforces needs more servers. This is insane. Okay, XYK. I should probably save problems. Okay, so X. No, the ceiling division. And now max of 2 times x minus 1, 2 times 1. That is correct. Let's make for C. I cannot load anything still. I wish I could load anything, but I can't. Okay, so when you have this grid, so you have a grid that looks like this. How many right triangles are there? So obviously you can pick this, but you can also do this. I think it's the only exception. That is the only exception. Okay, so oh, actually it's this. And then otherwise, we're just going to do, basically we're going to do minus 2, is that right? Can I load anything, please? I would like to submit problems. We're still like, we're like 8 minutes in. That's crazy. M1, M2. That's not what I was trying to do. It's actually insane. Submit problem D. Wrong answer. I got wrong answer? Oh, I forgot to, oh god. That was my fault. That was actually my fault. Oh, okay. And then check. Start times n plus n times n minus 1. Get some k prefix, minus get some k plus prefix, n minus prefix. If compute diff mid is still greater than equal to 0, then we're good. What just happened? Oh. Oh, oops. High goes mid. This is horrible. What am I doing? Okay. Then this is... wait a minute. If it's... this is actually raining. It's raining. Okay, can I submit? Please? Here, please. Everything's in queue. I can't load anything. Okay. That makes sense to start doing this. Now equals this. Now greater than this. I don't know. Yeah, let's read this. Let's see. P equals C. Concatenation. One, two, three, two, three, one, three, one, two. Okay, so. Oh. Oh, okay, okay. Yeah, okay, I know what to do. Right, so 1, 2, 3, 2, 3, 1. Right. So well, you can't just mod like that's not exactly. So right, so start is prefix right? That is where we start. So we start 2, 3, 1, which is 1, or we start 1, 2, which is okay, and then we need to do ans plus equals prefix sum start plus prefix sum on and minus prefix sum. Right. I think that is it. Excellent. Okay, I have to do this again. The website is still non-fiction. That's really bad. Alright, we're going to G. Set bi equals x. And set anything to anything. Minimum number of operations. Consecutive separate resistors. Okay, that makes sense. Yes, okay. At least k inside, okay. Sum from j equals L plus k minus 1 through R. So it's the sum of f of the subarray for every Oh, you just need to solve one subarray. Okay, cool. And then here, I need to solve a lot of subarrays, and here. Oh, the start changes, and got it. Okay. Makes sense. This site still won't let me. I've been using, I don't know. Okay. We just need to solve one subarray. How do we solve one subarray? That 8 is very unfortunate. One subarray is, I mean, oh, we just have some options for, oh, we just, right. Oh, it's just a distinct query. It's just a distinct query. This is still a case template. Oh no, we want the most frequent value. So what we need is okay, great. So we're going to change we're just going to change AI to +1, right? If I can do -1, then we're going to do the query. Which is really slow. So this hence I equals k minus big set. And then we are going to change L minus k minus 1 by negative. So Add spell. What happened? Do this? Is that the problem? What? Oh, this should be. Oh, this is. What? How is that possible? How is there a -1? What the hell? How did I get -1? What? I literally don't understand how I got -1. Oh, oh god. So bad. I can't believe I'm still using this in Form G. Okay, now we need to go through an output for every prefix. So what are we doing? We're just... I mean, you're just picking a separator besides K. Right, so now you have these numbers, and you're summing up the prefix mins. This plus min of this plus min of this. Oh, that's kind of interesting. How do you do that? this min of these two, min of these things, min. How do you do that? So you just compute closest left. I can't view standings. I guess I can't view standings. Okay. Yeah. I don't have a technique, it's kind of complicated. I have a technique. I mean, I could just do this, it'll work. Oh, I just use RMQ, just RMQ, and then, okay, so I'm going to compute suffix sum, right? I'm going to compute closest left right, which I'm going to do closest right in particular. Closest right in particular. Yes, vector into right equals closest right A, compare right, less than that. It's going to be, okay, so suffix sum right I plus right I minus I times AI. This needs to be this. Sure. Okay. Now I also need RMQ. Maximum mode should be false, RMQ on A, just build it. That I believe does just build it. I think I just built it. Cool. Not on A, on ants. On ants, sorry. This is also ants. This is also ants. A is dead. It's just ants. Okay. And in fact, this has length. N minus k minus 1. Because, yeah, okay. Now we're talking. So now we're cooking. Min index is rnq.query index L plus 1. And now suffix sum L minus suffix sum min index plus r minus min index times ants min index. That's what we are. What happened? What went wrong? Oh, this is, that's why. Not that that really matters, but. Oh, we got wrong answers that are not what we expect. The block is blocked. Yeah, people are trying to. Wow, okay. This is a rough queue. What went wrong here? 6? So we're going. We can't get this query right, actually, which is kind of strange. 4, 3, 7, or 2, 7. 5 minus, so it's just 1. Debug ants, debug suffix. I have to debug everything. This is kind of huge. Two, 3, 2. Yeah, 2, 3, 2. That seems reasonable. Suffix sum is 6, 5, 2, 0. That seems right. Oh, that is not. Oh, I see. That's this. R is dead. R is dead to us. Oh, and we do want this. What am I talking about? I think this will work. Submit G2. Thank you. We got G1. So that's nice, I guess. G3. So now, yeah, oh, we're still shrinking by k minus 1. And now we want the sum of the minimum of every subarray here. Ooh, how do you do that? That sounds fun. Okay. Every subarray. Okay, so we have that. We have that. For every subarray, we're summing them in. And the constraints are the same? 2e5, 2e5, 3 seconds. Okay, got it. You give us subarray, let's see this array. You're given a subarray, for every subarray, add up the minimum of the subarray. Is this, do this with seg tree or anything like that? So, no, that's not very convenient. But also, no, it's not fast. Let's do it that. I guess you can do it with, you can do it offline. No, that's kind of crazy. How do you do that? It's kind of unfortunate. I have no idea how anyone else is doing. Values don't change other than one side aside, so if you actually have this increasing thing, it's actually quite it actually goes to every number. Does that help? I don't know if it helps. So 656. Standings page is blocked. That's, I've never seen that before. Oh, what I really should have just done this. Right, then that would have just worked. Go to one. Okay. Wait, oh, wait a minute. You want suffix on here. Wait, no. Suffix on, suffix on. Oh, why did I do that? You didn't need to do that? Then open it twice. Okay, I'll just do this offline. So, because if I'm updating R, then for every L, I need to find min index, right? The min index when I update R, this becomes min index for some subset. Find the first thing less than it on the left. For all these, it becomes the min index. And if that becomes the min index, what does that mean? That means the answer here is oh, I also have to that's a little bit ugly. You can do this, it's just not simple. I wish I got this one. And then test 21. Is it just me, or is this actually kind of okay? There, just get stuff. This part is easy. But it's a little less easy, but it's still doable. It's still doable, it's for doable. This part is also doable. It's all doable. Is that the best solution? Is that the best solution I have? Should I actually go for it? Perhaps I should go for it. I have two different seg trees then. This is actually the worst I've ever seen in Codeforces Round. Okay, let's just do it. I need two types of sectors. I need a set. I need to set some secretary. And then I need to I don't know, this is probably overcomplicated, but I don't know what else to do. I need a set and sum section. Can I avoid the set and sum section? We just want sum, that's it. It's almost too simple to actually need to be a secretary. Okay, so that's really funny. Okay, well. I need to read the queries. I think it's just a set, so just gonna set up some of min, which is I. This is the range that we're. Oh, that needs to be. that seems fine. And then now, what are we doing? This. So we have that. This phase we've already taken care of. Answers q plus equals then index tree dot query from L to R. It's actually minus. This is minus, so that's because that's this part. And then finally we need another tree for wait a minute, what? So do I not even know how do I do this? I guess, I think I need to, okay, I can use the same tree again, which is nice. Arithmetic sum. Arithmetic sum. Let's get that. So we have this. I see, so we have but this is a little bit complex. This plus equals I don't want to do it. So okay, so that has length 1. Oh, length. I need to do this. That's a little bit crazy. Okay. But now we're good, because now we have what we want, and now answer I. Right, so now we need to do what is it? It's so this one's so 1, 2, 3, 4, 5. Times s3.query LR seg.sum minus seg.earthsum. Really? Okay. I mean, there's no way. I don't need basics. I'm sure just. Oh, right. This is the real problem. What? Oh, wait, I guess we don't want to do that? Oh, it's so close. Oh, the 6th value is wrong. How do I debug that? The 6th value is wrong. That would be this one, 1, 5 here, right? So let's isolate this. Yeah, there's 2, 4. Not 2, 5. Okay, that is what we want. Great. I don't use the on queue anymore. Interesting. Two and 1. So we want 2 plus 1 plus 1. Alright, so 3 1 still got 4. That looks good. And then minus suffix sum of min index, which would be 1 and 1. So it should be 2 after this. It is 2 apiece. Now here's the problem apparently. Two and 1. So 1 times 1 plus 2 times 2. That is that. But I set. Wait. This is still correct, right? Oh, it's not. Wait, I misunderstood. It's not min index, or it's not like the current index. Oh, that's much easier, isn't it? Oh, I'm so dumb. I don't need this. Oh wow. Okay. I don't need this, I just need some. right, so we finished this contest. We cannot see the scoreboard for pretty much the entire round, but to my surprise, when it finally loaded, I'm actually in first place. Very lucky here. There are actually 3 people here who finished before me, and all, maybe actually more than that, maybe like 6, 7 people, something like that. Anyway, who all finished before me and then just happened to get a little too much penalty. And yeah, I had a full clean submit record, so managed to squeeze out a win here. Nice. So overall, I actually thought it was pretty tough for a Div 4 round, mostly because of G, but I actually think that's fine. G is not super relevant for people who are actually Div 4 rated, and I thought A through F were pretty Div 4 level in terms of difficulty. But cool, let's go through the problems. I'll just go through these pretty quickly, just a lot to get through. So first of all, problem A, you're given A and B, and out of all possible values of C, find the minimum value of this. And yeah, if you just do the math, the C's cancel, so you're actually just always getting B minus A, and so that's what you do, you just print B minus A. So yeah, that's Div 4A. You can even iterate all values of C if you really want to, because it's only up to 10, so that would be fine too. Or you can notice it's just B minus A. All right, problem B. You've got a layout from your favorite rhythm game, and for each row you need to figure out what position the note is in. But for some reason they want you to print it backwards. I guess it scrolls from the top to the bottom. So yeah, for this I just saved the answers each time I read in a string, and I used string.find. So that was the easiest way to do this, then just reverse the answers and output. Actually, my first submit failed this sample because I forgot to increment by 1, so I actually printed 3210 here, but quick fix and then we're good. All right, C. So the frog is going from, Freya the frog is going from 0, 0 to x, y. In each move, she chooses an integer d between 0 and k and jumps d spots forward in the direction that she's facing. She faces positive x direction, then positive y, and then alternates. What's the number of moves that you need? So here we're going to use a pretty useful primitive here for ceiling division. So in general, if this were a one-dimensional problem, the number of moves you need is just the ceiling division of x divided by k. To do that without having to use any floating point, you can just, it's basically, this is the implementation I have that works for negative numbers as well. If you just have positive numbers, you can also do x plus k minus 1 divided by k. So that will give you the ceiling division. But anyway, just convert both of these to their ceiling division. And so in the one-dimensional problem, I need x moves to the right and y moves up. But since this is a two-dimensional problem and we're alternating x's and y's, basically, if we have x moves to the right, then we'll need at least 2x minus 1, because that's the move where we get the x move to the right, because it's x, y, x, y, x. So for example, if x is 3, we'll need these 5 moves, right? And then similarly for y, we need at least 2 times y moves. So if y is 3, we need at least 6 moves to get all those in. And so we just take the max of those 2, that's our answer. Cool, so that's C. All right, problem D. We're given endpoints in the 2D plane. The y value is always 0 or 1. And how many different non-degenerate right triangles can we form? Okay, so here you gotta analyze the situation a little bit. Basically your grid looks like this, right? And there's 2 ways to make a right triangle. One is relatively obvious. If you have a column that's both present, then you can use any other point to make a right triangle. It doesn't matter if it's on the left, or right, or on the top or on the bottom. The other point can be anywhere and it'll work. And then the only other case that works is specifically this case, and then obviously also you can reflect it. So you can also do this. But that's it. Those are the only cases that work. You can prove this by thinking about, for example, basically the reason this works is because the slopes are 1 and -1. But if you had a situation, let's say for example you wanted a slope of 1/2 or 1/3, well now you get to a problem because if you want to make a right angle here, you need a slope of -3, and that's not going to work with y values of only 0 or 1. So that's the basic idea why these are the only options. So these are pretty easy to count because there's only n options and you just iterate them all. And so that's what I'm doing here. So first of all, I make a grid. I just make the 2 by n, I guess 2 by n plus 1 grid, and just mark them. And then here, we're just counting this type of triangle, or this, depending on the y value. So it needs to be x minus 1 here, x plus 1 here, and then this y needs to be opposite from these two. Otherwise, if we have the column, then we can just add, this is the other case. When we find a column, we can just add n minus 2 because every other point will work with that column. And that's it. That's the entire code. So that's problem 10. All right. Cool. Moving on to problem E. So we've got an array A of length n. It's just a bunch of consecutive integers. And we want to choose an index so that we minimize, it's basically A1 sum through AI minus the sum of the rest. Take the absolute value and minimize that. So we want to find the answer. And n and k are big, so we can't actually make the array because we don't have time to make 1 billion values. But the key thing to notice here is that when you increase I, if you don't take the absolute value, when you increase I, this sum increases. Okay, so what does that mean? That means it starts negative and then it goes up and then it crosses 0 and then it gets more and more positive. And so we're only interested in the 2 points that are closest to 0. Basically the one that's negative and closest to 0 and the one that's positive and closest to 0. So if we find that I, we can just check the 2 options and then that's our answer. So the way we do that, there's a couple ways to do that. One is you can just solve the math to get it exact, and then you can get an O1 solution. But in terms of easier coding, what I would do is I would do binary search. So first I just have some helper functions. This gives you the sum of start plus 1 plus all the way to start plus n minus 1. So the n consecutive integers starting from the start. And then compute diff basically gets you the sum, or basically gives you this value for I equals prefix without the absolute value. And it just uses get sum twice. Cool. And then, yeah, we just do a binary search. What are we looking for here? We're looking for the last prefix that's greater than or equal to 0. Right. Or sorry, it's the first prefix, like the smallest prefix where the difference is greater than 0. And then our answer is we compute the difference there, or we compute the difference with 1 less, which would be negative. And then take the min of those 2 absolute values, that's our answer. So this runs in log time, which is more than fast enough. Cool, that's E. Problem F. Okay, problem F, we have an array A of length n, and we're creating a new array B where we concatenate all n cyclic shifts of A. So this B array has size n squared, and n is already 2 times 10 to the 5th, so we don't have time to create B. But it's fine, we don't actually need to. Yeah, and then we just have queries where we're trying to get the sum of a subarray from the lth element to the rth element. Okay, cool. So whenever you are looking for the sum of the lth element to the rth element, you should think about taking the prefix sum of the first r elements and subtracting the prefix sum of the first l minus 1 elements. So if we have a way to compute the prefix sum of any prefix of B, then we can do the subarray query as well. So, okay, let's just focus on the prefix sum query. Okay, so when we think about B, it'll be n repeats of the array, but each repeat is shifted, right? So let's say we wanted to find the sum of the first 7 elements of this array. In this case, n is 3. Well, what's the highest multiple of 3 up to 7? It's 6. So we have 2 full subarrays, or 2 full arrays of A here. So this is just 2 times the sum of everything in A. So if you think about it, yeah, basically we have some number of full arrays, and then we have a prefix of a cyclic shift. And we want to sum those up. And yeah, that's turns out to be pretty easy to do. The sum of the full arrays is very easy. And then the cyclic shift, what you do, or at least what I did coding-wise, is I appended A to itself. So A is now size 2n. It just itself repeated twice. Compute prefix sums on this array. And then what you'll notice is that, for example, if you want to get the first 2 of 3, 1, 2, then you'll have my array will be 1, 2, 3, 1, 2, 3. We'll start from the 3. So it'll be 1, 2, 3, 1, 2, 3. And then, yeah, start from the 3, and then we'll go this way, right? So in general, maybe if it's more illustrative, if I have a bigger array. Yeah, if I want to get the sum starting from 4 of the first 5 values, I will just get the sum of this subarray. And yep, that's pretty much it. That's what I'm doing here. So given the prefix, my answer starts with the number of full subarrays times the sum of the full array. Then I take the starting point, which is based on which shift are we, and then the length of that partial array is just prefix mod n. So this is the sum of that subarray here that I was talking about. And yeah, that's it. That gives you O1 query, so this problem is done. Cool. So that's A through F. Yeah, that's what I meant by A through F are relatively easier and are definitely more Div 4 level. A lot of people finished A through F in, I guess, somewhere around, a lot of the top people finished in somewhere around 20 minutes. And then G, yeah, was significantly harder than, really, than everything else combined. But it also had 3 parts, so. All right, let's go through it quickly. So G1. So first of all, in this problem, all the problems subtasks are like fairly similar. It's just that the query is a bit different. In G1, the query is just a single subarray. In G2, the query is a sum, and in G3, the query is a sum of sums. Okay, cool. Yeah, so here, the foundation of the problem for all 3 versions is you have an arbitrary array B, and you can perform this operation any number of times. Set any element of the array to any number, any integer you want. And then you need to find the minimum number of operations you have to do until there's a consecutive subarray of length at least k and b. Consecutive just means it's incrementing 1 by 1. So, for example, if k is 4, the subarray could be 6, 7, 8, 9. Cool. And then in G1, I mean, they write the sum, but you don't actually need to worry about the sum. You're just given a subarray of length k, and you need to figure out the answer for that subarray. Okay, so first idea for this problem is, let's say you want to solve a subarray of length k. What you need to do is basically, obviously, one thing you can do is that you can change all k elements, but if you want to get less than k, you need to keep one of them fixed, right? Let's say we keep this 4 in the middle fixed. Okay. Then we clearly need to make 2, 3, 4, 5, 6, right? And you can actually, enumerate this out for every value. So if we keep the 5 fixed, we need 5, 6, 7, 8, 9. If we keep the middle 4 fixed, we need 2, 3, 4, 5, 6. Both of these are not very helpful because we still need to do k minus 1. But you'll notice if we pick any of these 1, 3, or 4, we need 0, 1, 2, 3, 4. And this actually only requires 2 changes, this one and this one. The reason it requires 2 changes is because this number, and this number all generate the same array. And the reason they do that is because we should actually look at the value ai minus I, right? And so in that case, when we have 5, 1, 4, 3, 4, that transforms into 5, 0, 2, 0, 0. And these zeros tell you that these values basically create the same array, right? So because there's 3 zeros here, we know that in the best case, we only need to change 2 values, which are the 2 non-zero values. Cool. So the first thing to do is change the array a into ai minus I. Here actually I did ai minus I, but then I added n minus 1 just to keep everything at least 0. Cool. And then now that we do that, now what we want to do is for every subarray of length k, query what is the most frequent value and how frequent does it occur. So I do this, there are a lot of ways to do this. I do this by keeping a multi-set of the frequencies, and then basically I'll add each value in, and then once our size gets to at least k, then I'll remove the value to the left. So I'll just have this like sliding window of size k, right? And yeah, just erase the old frequency, update it, and then insert the new frequency. Be careful though with multiset, don't do freqset.erase because that will erase every instance of that number, whereas you just want to erase one instance of that number. It's funny, I don't think I've ever wanted to use multiset and wanted to erase every instance of a number. So I would actually prefer this behavior as the default, but anyway, quick thing you need to remember. Cool, and then after that, you've actually computed every answer, so I just print the answer. Super simple. All right, that is G1. Now for G2, we're given a subarray that's length at least k, and we want to sum the answer for every subarray that is a prefix of this array and has length at least k. So now the better way to think about it, let's actually forget the array A. Let's just take our ants array. Okay, and now what we're actually doing is the query actually looks like ants L plus min ants L plus 1. This is actually the query from L to R once you subtract k minus 1 from R and subtract 1 from L. So this is actually the query we're going for, because basically if you have a subarray longer than k, then you're just taking the minimum answer out of every subarray of length k in that subarray. So here we have an array ants, and we just need to compute the sum of the prefix minimums in the subarray. Cool, so how do we do that? The way we do that is I use something called closest right. It finds for each index, the closest index to the right that is less than that index in value. And then I do this thing called suffix sum, which is basically, it's the sum of starting from this point, it's the sum of the min of every prefix from this point. Cool. And the way that works is you take right I, which is the first thing that you run into less than this, take the suffix sum there, and then otherwise you know that everything in between is just our current value. So that's how we do that. And then, then I use RMQ to find the minimum index overall in L through R, right? And so I take suffix sum L minus suffix sum min index. That gives me the sum of all this part. And then and then I know that the min for every remaining part of my query, once we hit the actual min index, all these mins will be answer for min index. And so that gives us this, because this is how many of them there are, and this is the value. So that's G2. Okay, cool. So that's G2, and now we get to G3, which is significantly harder, which is now, instead of just every prefix, we want the sum in our subarray for every subarray of length at least k of the answer for that subarray. So again, we can forget about the original problem, think about the answer array, and now we're just doing, it's just the sum for every subarray between L and R of the min of that subarray. Okay, Cool. So how do you do that? So the way I thought about that, I mean, I just approach it as kind of an extension of G2. And you want to get the sum of all of these for all of the different L values. Cool. So this is pretty easy. You just sum the L value for every L value in the range. That is standard prefix sums. So this, I thought this kind of hilarious because I'm taking prefix sums of suffix sums. But yeah, that's this part. So this computes this part. Now we're going to compute this part. Actually, we're going to do all three of these with the same technique. What I do is I have a seg tree where basically I only have two operations. One is set all the values in a range to some value. And then the other is query the sum of a range. That's it. Cool. And I do this for three different things. So first I do it for this. And the way I do it is I have to sweep R. So I sweep R from left to right. And then it's funny, I actually need to use closest left to compute the first thing on the left that is less than our current value. Because when we add a new value, that tells us how far back we can go and still be the minimum. And then, yeah, I'm going to update this because we're basically finding out how many L's we're the min index for. So we are the min index for this range. We're going to update this range to have our suffix sum. So that's the suffix sum tree. Then I need the sum of ants min index tree. So that's the ants tree. Same thing here. I'm just putting in ants for that range where we're minimal. And then I need this min index times ants min index value. And that is an ants I tree where we're putting in I times ants I into this range. Okay, cool. So that's what we need, 3 trees. And then finally, we're going to iterate over all the queries at R. So this is offline. If you really want to make this online, you can do persistent trees, but you don't need to here. Go through that query, we get L. And then, yeah, we're just doing all these things. So we've already done this. Already done this part, that gives us this. Then we're going to do this, right? And that is the suffix sum tree query. Then we're going to do R times ants min index, and that is R times ants tree query. And then we're going to do this minus min index times ants min index, and that is ants I tree query. Cool. So that's everything. Just do all these things, and then yeah, we're done. So, so yeah, we actually solved the general problem, which is you just have an array and you want to query for some subarray. What is the sum of the minimum of every subarray inside that subarray? And this gives you a way to do that. So yeah, it was pretty cool how this basically kind of navigated smoothly from solving G1 to G2 to G3. Kind of curious if other people did this similarly, but I guess we'll find out after the contest. Anyway, nice little win. Wasn't expecting it, but it was a fun one. And anyway, cool. See you in the next one.